In recent months, something unexpected has begun to happen with our star. The Sun, which in recent decades had shown relatively calm behavior, is revealing a restlessness that surprises even the specialists. Sunspots have appeared more rapidly than predicted, geomagnetic storms have reached unusual intensities, and several coronal mass ejections have exceeded what models anticipated. It's as if the heart of our system has decided to beat stronger than expected, an accelerated pulse that travels through space and inevitably reaches us here on Earth. The solar cycle is well known. 11 years of ascent, a maximum of activity, and then a gradual decline. This regularity has allowed astronomers to predict with some confidence how our star will behave at each stage. However, recent data have altered this sense of stability. The Sun seems to have awakened with a vigor that was not yet expected. For many researchers, it is a sign that the coming years could be marked by a more active solar maximum than in previous decades. And right at this very time, as if the synchronicity were deliberate, an object from another star system is advancing towards its perihelion. A comet that does not belong to our neighborhood. A visitor whose trajectory is one way and will never return. Its name already resonates in the astronomical community. 3I Atlas. Imagine for a moment what this coincidence means. A star that is beginning to show a fiercer, more unpredictable face, and an interstellar traveler crossing our solar system right now, when conditions seem more intense than ever. There is no evidence connecting them, no proof that one influences the other. But in the cosmic story we share, the coincidence carries a weight that goes beyond mathematics. Because the sky is not just observed, it is also narrated, and what is happening today lends itself to be told as a shared mystery between two protagonists who rarely coincide. The Sun, when it stirs, reminds us of the fragility of our technological life. A solar storm directed towards Earth can disrupt communications, affect satellites, interrupt electrical systems, and even put space missions at risk. At the same time, this interstellar comet is an unrepeatable gift for science. Unlike the comets we know, bound by closed orbits to the Sun, this object will never return. It is a fragment of another time and another system that is now offered. For a few months, to our observation, and so, two separate phenomena converge into a single narrative: the awakening of our star and the arrival of a stranger. Before continuing, just a brief note. If you enjoy listening to these stories of the universe told calmly, you can subscribe so you don't miss future journeys. And in the comments, tell us from where in the world you are listening. Together, we form a constellation of voices that lights up every night on this channel. Let's return to the mystery, because what is coming is not common. During September and October of 2025, the sky has been filled with visitors. Asteroids passing by, comets appearing, and among them, this interstellar traveler that stands out above all others. 3I Atlas is not just any comet. Its chemical composition is baffling. Its green glow is surprising, and the anomalies it presents make it an object different from those we know. And meanwhile, our Sun increases its activity with unexpected force, as if responding to a presence approaching from the darkness. Of course, science reminds us that these are coincidences. The solar maximum occurs every 11 years, and this one is simply more intense than predicted. Interstellar comets, though rare, are part of the natural dynamics of the galaxy. Fragments ejected from other star systems that occasionally cross ours. There is no proven causal relationship, but that doesn't take away from the story's power, because what really captivates when hearing it is not the statistics, but the feeling of witnessing something unrepeatable: the awakened Sun and a comet from another sun sharing the same temporal stage. Let's think about the image. If we were to pull back and contemplate the solar system from afar, we would see our star launching flares, showing more sunspots than usual, surrounded by a denser solar wind. And, from another direction, we would see a bright comet approaching, with its greenish tail extending like a veil that carries the secrets of its origin. Two moving lights, two different forces, converging in a dance that seems rehearsed for this moment. That vision is what gives the story an air of destiny, of connection between phenomena that, although separate, awaken our curiosity together. This is the beginning of our exploration. In the next sections, we will talk about how solar activity is measured, what effects it has on Earth, how an interstellar comet behaves when entering our system, and what specific anomalies make 3I Atlas such a strange visitor. But before getting into the details, hold on to this idea. September and October of 2025 are not ordinary months. They are months in which the sky seems more alive, more restless, more willing to remind us that the universe is not a static stage, but a work in constant motion. And we from this small blue planet are fortunate to be witnesses. The sun, our close guardian, shows itself with a fiercer face. And at the same time, an interstellar traveler approaches, shining with a glow different from that of our homegrown comets. Two protagonists, two stories that converge, and a single opportunity to contemplate them together. What is coming is not just any event. It is a cosmic coincidence that invites us to look up and ask, what is the universe telling us? When we say the sun is showing unusual activity, it's not a metaphor. It's a diagnosis based on very precise measurements that astronomers and solar physicists carry out day after day. To understand it, it's helpful to remember that the sun is not a uniform ball of fire burning constantly. It is a sphere of plasma, crisscrossed by currents, magnetic fields, and internal cycles that determine its behavior. That behavior has a rhythm, what we call the solar cycle. Each cycle lasts approximately 11 years. It begins at a minimum when there are few sunspots and the sun's surface appears relatively calm. Then, little by little, the activity increases. Sunspots multiply, eruptions become more frequent, and the energy the star releases into space grows. This leads to the solar maximum, the most intense point of the cycle. Afterward, the activity subsides, the spots diminish, and we return to a minimum. This has been the case for centuries, and the records confirm it. A cosmic breath, a heartbeat that repeats with astonishing regularity. But regularity doesn't mean monotony. Each cycle has its own character. Some solar maximums are intense, with storms that light up Earth's skies with auroras visible even at low latitudes. Others are more timid, almost discreet, as if the sun were at rest. Astronomers expected the current cycle, number 25 since we began counting them, to be moderate. However, the data from recent months tell a different story. Sunspots have multiplied faster than expected. The intensity of the eruptions has surprised specialists. The levels of radiation and solar wind exceed the predictions of the initial models. What does this mean in practical terms? It means our sun is proving to be more active than predicted, more unpredictable. And it is this unpredictability that generates interest. For the scientific community, it is a golden opportunity to review models, adjust theories, and better understand the star's internal mechanisms. For those of us living on Earth, it is a reminder that our technology is always at the mercy of this star, because although the sun gives us life, it can also test our systems. Imagine a solar storm. It all begins with an eruption on the sun's surface, a flare that ejects an enormous amount of energy and charged particles into space. If this ejection is directed toward our planet, the first thing we see are spectacular auroras, curtains of green, red, and purple light unfolding in the night sky. But along with the beauty come the risks. These particles can interfere with radio signals, alter satellite orbits, damage electrical systems, and, in extreme cases, cause blackouts in entire cities. We are not talking about science fiction. This has happened before. The famous Carrington event of 1859 is a historical example. Telegraphs of the time caught fire, tower lines failed, and auroras were seen as far as tropical latitudes. In the 21st century, such an event would have even more serious consequences. We don't live with telegraphs, but with the internet, navigation satellites, space stations, and a global electrical grid that sustains modern life. Each increase in solar activity reminds us that no matter how much we have advanced, we remain vulnerable to the winds of our star. And that is precisely what makes the current activity so relevant. The sun is more restless. And that means we must be more vigilant. Now, what exactly do astronomers observe? To begin with, sunspots. They are dark regions on the sun's surface, cooler than their surroundings, caused by intense concentrations of magnetic fields. The number and size of these spots are a thermometer of the star's state. In recent months, these spots have been larger and more numerous than expected for this point in the cycle. Then there are solar flares, bursts of energy that release radiation across the entire spectrum, from radio waves to X-rays. Several of these recent flares have reached the highest categories on the scale scientists use to measure their power. And finally, coronal mass ejections, enormous clouds of plasma that the sun launches into space. Some of them have been so intense that they reached Earth's magnetosphere, generating auroras in places where they are rarely seen. The inevitable question is, why now? The answer is not yet entirely clear. There are hypotheses that speak of natural fluctuations, small variations in the sun's internal dynamics, that make one cycle more active than another. Other researchers believe that we still do not fully understand the magnetic processes that govern solar activity, and that each cycle offers us an opportunity to adjust our theories. In any case, the fact is that we are seeing a more intense awakening than predicted, and that makes the sun the absolute protagonist of this astronomical season. For observers on Earth, this also has a fascinating side. The auroras borealis and australis have become more frequent and visible in places where they were once rare. In cities across Europe and North America, people have been able to look up at the sky and see curtains of light waving like veils in a cosmic theater. For many, it is the first time in their lives they have witnessed such a phenomenon. And although technological risks are hidden behind this beauty, there is also an opportunity to connect with nature in its grandest expression. Science, as always, seeks balance. On one hand, the opportunity to collect data and learn is celebrated. On the other, there is a warning about the need to prepare for possible consequences. Space agencies, electric companies, and governments are working on protocols to minimize the impact of severe solar storms. But beyond the logistics, there is a deeper reflection. The sun is not an immutable constant. It is dynamic, changing, sometimes serene, and sometimes tempestuous. And we, inhabitants of a planet dependent on its energy, must accept it as such. This is the stage that greets us as our story begins. The sun is stirring, awakening with more force than expected. And in the midst of this awakening, an interstellar visitor is advancing towards its closest encounter with the star. Two very different protagonists, but who share the same cosmic stage. One is our guardian, the source of all we know. The other is a stranger, a fragment from another place that fleetingly crosses our world. And the coincidence of both at this time makes September and October of 2025 feel different, more alive, more charged with mystery. Because it's not just about observing sunspots or calculating trajectories. It's about feeling the awe of being present at a moment when the sky seems to speak to us with more intensity than usual. The sun reminds us of its power. The comet reminds us of our smallness. And together, they invite us to look up and wonder what else the universe has in store for us. To speak of a more active sun is not just a matter of astronomical observations or charts full of numbers. Solar activity has real, tangible consequences that reach down to everyday life on Earth. It may seem distant, like a phenomenon reserved for scientists and telescopes, but the truth is that every solar storm, every explosion on the surface of our star, can be felt down here in ways we often don't imagine. To understand it, it is useful to go step by step through what happens when the sun enters a phase of agitation and what implications it can have for us. The first thing to understand is that the sun does not only emit light and heat, it also launches a constant stream of charged particles that we call the solar wind. This wind blows outward in all directions, bathing the entire solar system. When the sun's activity is low, the wind is more stable and less intense. But when the sun gets restless, these currents become denser, faster, more unpredictable. Each coronal mass ejection, each solar flare, adds an extra pulse of particles that travels through space at speeds of hundreds or thousands of kilometers per second. This is where the Earth's invisible shield comes into play, its magnetic field. The magnetosphere acts as a barrier, deflecting a large part of these particles so that they do not reach the surface directly. Without it, life as we know it would be impossible. However, this barrier is not indestructible. When a solar storm is strong enough, it can compress the magnetosphere, open temporary cracks in its structure, and allow some of the energy to penetrate deeper into our environment. The immediate result is the aurora, those light shows that paint the sky in shades of green, red, and violet. But the consequences don't stop at beauty. One of the best-known effects is interference with communications. Charged particles can disrupt radio waves, especially at frequencies used for air and sea navigation. In severe storms, signals can disappear for minutes or hours, complicating the work of pilots and controllers. Something similar happens with satellites. High-energy particles can damage circuits, alter orbits, or even render a piece of equipment unusable. In an era where we depend on satellites for communication, global internet, weather, and geolocation, this risk is more serious than it seems. Electricity on Earth is also vulnerable. When the solar wind interacts with our planet's magnetic field, induced currents are generated in the power grids. If these currents are too strong, they can overload transformers and distribution systems. It has happened before. In March 1989, a solar storm caused a massive blackout in Quebec, Canada. Millions of people were left without electricity for hours, all because of an explosion on the sun that had occurred days earlier. Astronauts and space missions are another critical point. On the International Space Station, astronauts have partial protection thanks to the Earth's magnetic field, but not complete protection. When a strong storm occurs, they often have to take shelter in more protected areas of the station. For more distant missions, such as those planned for the Moon or Mars, solar radiation is a huge risk that requires advanced shielding systems. A storm at the wrong time could endanger an entire crew. Beyond the technical, there is a cultural and human impact. Every time a solar storm produces visible auroras in places where they don't usually appear, thousands of people leave their homes to look at the sky. In cities in Europe, North America, and Asia, recent increases in solar activity have allowed those who have never seen an aurora to witness this spectacle for the first time. Social media fills with photos and videos, sharing the feeling of collective wonder. It is a reminder that we are still, deep down, creatures who look up for signs, although today, we do it with cameras instead of myths. Science also takes advantage of each of these storms. Specialized satellites like the Solar Dynamics Observatory, or more recent missions like the Parker Solar Probe, collect precious data every time the sun stirs. This data allows us to study the star's internal mechanisms and improve the models that predict its behavior. It's not just curiosity. Understanding the sun is vital to protecting our technology and ultimately our way of life. But there is an interesting nuance: unpredictability. Despite all we know, solar storms still surprise us. We can anticipate a solar maximum, we can estimate trends, but we cannot always predict the exact magnitude of an event. It's like living next to a volcano. We know it will erupt, but we can't always know when or how forcefully. The sun, in its current phase of awakening, reminds us of this reality. Now, what does all this mean in the context of our story? It means that, at the very moment the sun becomes more active than expected, an interstellar visitor is approaching its perihelion. There is no proven link between the two, but the coincidence is powerful as a narrative, because while we think about the risks of a solar storm for our cities, we also hear news of a comet that we will never see again. A fragment from another system that is fleetingly crossing our neighborhood. And in this overlap of phenomena, the sky becomes a double stage. On one side, our restless star. On the other, an interstellar traveler. The connection is narrative, but no less significant. It forces us to look up with more attention. The sun can alter our immediate present, while 3I Atlas reminds us of our smallness in the face of the immense cosmos. One touches us with its strength. The other visits us with its mystery. Together, they form the plot of this unrepeatable time. In the end, the consequences of an active sun are not limited to technology or auroras. They also have to do with our perception. Every time the sky lights up with dancing lights, every time we hear about a blackout caused by a solar storm, we remember that we depend on a star that, although it seems stable, has its moments of fury. And to the extent that we understand it, we also better understand our vulnerability and our ability to adapt. That is why talking about a more active sun is not just talking about science. It is talking about ourselves, about how we live under the protection of a star that gives us everything and that at times puts us to the test. And at this particular moment, when solar activity coincides with the approach of a comet from another system, the story takes on a special nuance. As if the universe wanted to remind us that there are always greater forces acting in parallel, and that our task is to observe, understand, and marvel. The unexpected protagonist of this story is not a star or a planet. It is a lonely traveler arriving from beyond our cosmic frontiers, the interstellar comet known as 3I Atlas. Its name may sound technical, almost cold, but behind those acronyms lies one of the most fascinating rarities that modern astronomy has been fortunate enough to observe. To understand its importance, one must remember that, for most of human history, comets were seen as omens. Sudden appearances in the night sky, with bright tails and unexpected trajectories, were interpreted as signs of war, plague, or changes in the fate of kingdoms. Today, we know that comets are bodies of ice, rock, and dust, fragments left over from the formation of planetary systems. However, until recently, all the comets we knew shared a common origin. They were born along with the sun, in the cloud of gas and dust that shaped our solar system. That changed in 2017 when we detected Oumuamua, the first confirmed interstellar object. Its brief and mysterious passage opened a window to the possibility that fragments from other systems could cross ours. Shortly after, in 2019, Borisov appeared, another visitor, this time with characteristics more similar to a conventional comet. And now, in 2025, the story surprises us with a third chapter, 3I Atlas, the third confirmed interstellar object and the second to show clearly cometary behavior. 3 visitors in less than a decade, after centuries of observations with no record of any, is a change that forces us to rethink what we believed about the frequency of these phenomena. Where does 3I Atlas come from? That is the big question. Its orbit is not bound to the Sun. Unlike known comets, which follow elliptical trajectories around our star, 3I Atlas travels in a hyperbolic orbit, which means its passage is one way, not a return trip. It arrived from interstellar space, and after crossing our system, will continue its journey to another corner of the galaxy. It will never return. This condition makes it a unique object. We have only one chance to observe it, to measure it, to learn from it. The discovery was made in July 2025 thanks to the ATLAS, Asteroid Terrestrial Impact Last Alert System, a set of automatic telescopes designed to detect near-Earth objects that could pose an impact risk. It was in the mountains of Chile that the ATLAS cameras captured a point of light that did not match any previous record. By analyzing its movement and calculating its orbit, astronomers understood that it was not just any comet. Its hyperbolic trajectory revealed it as a visitor from another star system. Thus, its official name was born, 3I Atlas. The number 3 indicates that it is the third confirmed interstellar object, after Oumuamua and Borisov, and the acronym ATLAS honors the project that detected it. Since then, 3I Atlas has become the center of attention. Ground-based telescopes, space observatories, and even missions that originally had other objectives have turned their gaze towards it. The reason is simple. Studying an interstellar object is like receiving a time capsule from another place in the galaxy. Every piece of data about its composition, its behavior, and its interaction with the Sun gives us clues about the processes that occur in planetary systems that are not our own. In other words, observing 3I Atlas is a way of doing comparative science. We can ask how comets from different parts of the Milky Way are similar and different. One of the first surprises upon observing it was its greenish coma, a glow that distinguishes it from many common comets. That color comes, in large part, from the decomposition of diatomic carbon molecules when they interact with sunlight. It is not exclusive to 3I Atlas, but the intensity and the timing of its appearance drew attention. Then came other findings. The proportion of carbon dioxide in its coma is much higher than that of water, a fact that radically differentiates it from the comets we know. Uncommon molecules, such as OCS, carbonyl sulfide, were also detected, which opens new questions about the chemical conditions of the system from which it comes. Another interesting feature is its distant activity. Typical comets usually show signs of sublimation, the process in which ice turns directly into gas when they are relatively close to the Sun, generally within 3 astronomical units. However, 3 Atlas showed activity beyond this distance, suggesting that it has more volatile ices or structures that make it behave differently. Detecting water and OH at more than 3 astronomical units was a surprise that is still being analyzed in detail. And then there's its rotation. Calculations indicate that it rotates approximately every 16 hours, a stable rhythm compared to other comets, some of which exhibit chaotic spins or even abrupt changes in their rotation period. This detail, though seemingly technical, provides clues about its internal structure, its cohesion, and the history of collisions it may have experienced in its place of origin. All this makes it a jewel for research. We rarely have the opportunity to study such a pure fragment, uncontaminated by thousands of passes around the Sun. 3 Atlas arrives fresh, in a sense, with its original composition practically intact. It is as if someone dropped a stone from another world into our neighborhood, offering us the chance to analyze it before it continues on its eternal path. From a narrative point of view, it is also irresistible. an interstellar visitor that arrives just as our sun awakens with a more intense activity than usual. The stage is set for questions. Is it just a coincidence? What does it mean for us that in less than a decade, we have seen 3 interstellar objects? Is it possible that the galaxy is much more full of these travelers than we thought? On the scientific level, the most likely answer is that they were always there, silently crossing space, but our telescopes were not sensitive enough to detect them. The improvement of technology, along with dedicated projects like ATLAS or Pan-STARRS, has increased our ability to discover what previously went unnoticed. But even so, the feeling of living through a historic moment does not disappear. Each new interstellar object reminds us that we are not isolated. We share the galaxy with fragments of distant worlds that from time to time cross our path. 3. I-Atlas will not be visible forever. Its most notable approach will occur in the coming months, and then it will move away, never to return. It is a fleeting visit, a unique opportunity, and that is why every observation counts. Every recorded piece of data, every analyzed spectrum, every image obtained is part of an archive that we may never be able to repeat. At this point in the story, we already have our 2 protagonists on the stage: the Sun, restless and more active than expected, and the Comet 3I Atlas, the interstellar traveler approaching its closest encounter with our star. From here, the plot becomes even more fascinating, because we are not only going to talk about their individual characteristics, but also about the coincidence of having them together at this time. And that opens the door to hypotheses, to comparisons, and to reflections that transcend science to become a story. Now that we know 3I Atlas as an interstellar visitor and have introduced it as the protagonist of this story, it is time to follow its journey. Every comet has a unique path, but that of 3I Atlas is unlike that of the comets we usually study. The reason is simple. It was not born here. Its origin is in another star system, and that is reflected in the way it travels. Its orbit is not an ellipse that binds it to the Sun, but an open, hyperbolic curve that betrays its status as a foreigner. When astronomers calculate trajectories, they use information obtained from multiple observations. In the case of 3I Atlas, from the very first records, it was evident that its speed was too high for it to belong to the group of comets born in the Oort cloud, that distant reservoir of our own system. While a comet of local origin can travel at tens of kilometers per second, 3I Atlas does so at almost 60 kilometers per second, a speed impossible for the Sun's gravity to break. In other words, it entered, we are watching it pass, and it will exit, never to return. The point of closest approach to the Sun, known as perihelion, will occur at the end of October 2025. That will be the moment when its trajectory will bring it to a distance of about 1.4 astronomical units. For those who are not so familiar with the term, an astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometers. This means that the comet will not pass between the Earth and the Sun, nor will it approach in a dangerous way. Its perihelion will be beyond Earth's orbit near the region where Mars moves. This information is important because it helps to quell possible misunderstandings. Every time a comet approaches, rumors and speculations arise about imminent collisions or threats to our planet. But 3I Atlas poses no impact danger. Its path is clear and well calculated. It will not collide with Earth or any other planet. What it does offer is an astronomical spectacle and a unique opportunity for research. As it approaches its perihelion, its activity is expected to intensify. Comets, upon receiving more solar radiation, begin to release gases and dust with greater force. In the case of 3I Atlas, it has already shown atypical behavior at greater distances, so it is reasonable to think that near the Sun it will reveal even more surprises. Perhaps we will see an increase in its brightness, more developed tails, or even bursts of activity that do not fit the usual models. Telescopes around the world will be watching for every change. Another interesting feature of its trajectory is the angle at which it enters the solar system. Unlike many local comets that travel in planes similar to those of the planets, 3I Atlas crosses from a marked inclination, as if it were coming from above the cosmic stage, entering obliquely and passing through the planetary neighborhood. This adds difficulty to the observations, but it also offers unique perspectives. Astronomers will be able to see it from unusual angles, which helps to study its three-dimensional structure and its gas and dust tails. A journey of 3I Atlas is also an invitation to reflect on the vastness of space. To get here, it must have traveled distances that defy imagination. We do not know exactly from which star it departed, but we can affirm that its journey has lasted millions of years. Perhaps it was ejected from a forming system where the gravity of giant planets threw it outward. Perhaps it was born in a protoplanetary disk that no longer even exists, around a star that transformed over time. Be that as it may, what we observe today is the result of a cosmic exile, a fragment of another world that after an unimaginable journey passes fleetingly through our sky. Meanwhile, on Earth, scientists are preparing their instruments. The passage of 3I Atlas coincides with the era of the greatest technological capacity in the history of astronomy. We have space telescopes like the James Webb, capable of analyzing the chemical composition of its coma in detail. We have ground-based observatories that track its brightness, its tail, and its variations. Even probes that orbit the Sun, like the Parker Solar Probe, could provide indirect information on how this visitor interacts with the solar wind. All of this makes its journey to perihelion not just a spectacle, but a natural laboratory open before us. At this point, an inevitable question arises. What will we see when it reaches its closest approach? No one knows for sure. Comets are notoriously unpredictable. Some become bright, visible even to the naked eye from Earth. Others fragment and disintegrate before putting on a great show. Recent history is full of examples of both extremes. With 3I Atlas, the only thing certain is that it will behave differently from local comets because its origin, its composition, and its structure are not the same. The temporal coincidence with the unusual activity of the Sun adds a special nuance, because when the comet is at its perihelion, our star will also be in a phase of greater agitation. This means that the interactions could be even more notable. An active Sun releases more radiation, more solar wind, more high-energy particles, and a comet at full perihelion is particularly sensitive to these forces. Thus, the encounter of both phenomena is not only a narrative coincidence. It can also translate into fascinating scientific data. Visualize it as a cosmic stage. On one side, the Sun launching flares, expanding its influence with more intense storms. On the other, an interstellar comet passing through that storm with its tails unfurled, shining with a glow that reflects its strange nature. Both coincide at the same time and place, like two actors who rarely share a scene, and we, the spectators, are fortunate to witness it. This path towards the Sun, though brief in astronomical terms, is a journey laden with meaning. It reminds us that we live in a dynamic universe where improbable encounters happen more often than we imagine. I-Atlas will not stay. It will not circle our star. Its visit is fleeting, a single opportunity that we must seize. Because once it crosses its perihelion and moves away, it will be lost in the vastness of space, heading for destinations we will probably never know. In summary, the path of 3I Atlas towards the Sun is the central chapter of this story. An interstellar comet, approaching its perihelion just as our star shows signs of increased activity. It is not a threat. It is not a catastrophe. It is a cosmic encounter that combines science and mystery. And in the coming sections, we will explore what this coincidence means, what anomalies make this visitor such a different object, and what reflections the possibility of witnessing such a unique crossing in time awakens in us. Sometimes, the universe seems to have a strange sense of synchronicity. Two independent phenomena, each with its own causes and explanations, occur at the same time and place, as if they had agreed to share the stage. That is what we feel when observing the current state of the sky, a sun that is stirring with more force than expected, and an interstellar comet crossing our system for the first and only time. Separately, both are notable events. Together, they form a coincidence that sparks our imagination. From a scientific perspective, we know that there is no direct relationship between solar activity and the arrival of 3I Atlas. The Sun obeys the 11-year cycles that govern its magnetic field, and the comet is merely a visitor whose trajectory was decided millions of years ago, long before humanity existed. There is no causal connection. But if we step away from technical rigor and allow ourselves to observe the narrative from a more human angle, a coincidence takes on an almost poetic nuance. Imagine the scene. Our star, after years of relative calm, begins to show a fiercer face. Sunspots multiplying, flares traveling millions of kilometers through space, auroras visible at unusual latitudes. And just then, from the far reaches of the galaxy, a strange visitor appears, a comet that will never return, a fragment of another world crossing our neighborhood. Is it mere chance? Yes. Is it fascinating? Also, yes. Human thought has a long tradition of seeking meaning in cosmic coincidences. Our ancestors did it with every eclipse, with every alignment of planets, with every sudden appearance of a comet in the sky. Today, we know more. We have scientific explanations for what happens, but the sense of wonder is still there. Because it's not just about data. It's about what we feel when we witness these improbable encounters. In this case, the coincidence is doubly significant because both phenomena remind us of different aspects of our relationship with the cosmos. The sun, in its awakening, reminds us of our fragility. We depend on its light and heat, but we are also exposed to its storms. Every increase in its activity is a reminder that modern life, sustained by satellites and electrical grids, is not isolated from the behavior of our star. And 3I Atlas, in its fleeting visit, reminds us of our smallness. We are just a dot on the path of a traveler who would cross and be lost without looking back. The overlap of both phenomena makes September and October of 2025 unrepeatable months. It is as if the curtain of the sky has opened to show us a special act, a play in which a familiar actor and a completely new one participate. The sun, which has always been there, now showing a more intense side, and the comet, which had never been and will never be again. The coincidence is not scientific, but it is narrative, and it is this narrative that captivates us. There is something deeply human in wanting to connect the dots. Even though we know there is no relationship, we can't help but wonder, what if there were? What if the arrival of an interstellar object coincided with a solar awakening because there are forces we do not yet understand? And what if what we see today as chance were, in fact, part of a larger pattern we have yet to discover? Science will say no, that they are independent processes. But imagination, that tool that makes us human, will always want to explore those questions. The coincidence also serves as a reminder of the vastness of the galaxy. The Sun, with its storms, is a local phenomenon, a star 150 million kilometers away, the center of our small system. 3I Atlas, on the other hand, represents the external, the distant, the unknown. By coinciding, they force us to look in two directions at once: inward, towards what affects us immediately, and outward, towards what connects us with the immensity of the Milky Way. Imagine telling this story centuries from now. The records will say that in the year 2025, while the Sun was showing unusual activity, an interstellar comet crossed the system. For those who read those lines, it will be just a note in the history of astronomy. But for us who are here, it is a living experience. It is the sky reminding us that it is not still, that it always holds surprises. A cosmic coincidence also has an emotional effect. It reminds us that the universe is not an empty and silent place, but a vibrant stage where multiple stories are happening at the same time. That suddenly a near and a far phenomenon coincide on the calendar gives us a sense of connection, even if we know it is by chance. It is like listening to two different melodies that for a moment sound in harmony. In this sense, the coincidence becomes a powerful narrative device. Scientists can separate both phenomena in their models and analyses. But for those of us who tell stories of the universe, the value lies in uniting them, in showing them as part of the same story. Because science explains, but narrative connects. And on this channel, that connection is what we seek. For data to become experience, for information to become companionship. Thus, September and October are not just months on the calendar. They are chapters in a broader story, a story in which the Sun awakens and an interstellar comet accompanies it. It may be that in a few months, everything will return to normal. The Sun will continue its cycle, the comet will be lost in space, and we will continue with our lives. But during this brief period, we can stop, look up, and feel that we are witnessing something unique. That is the essence of the cosmic coincidence. It doesn't change the course of the universe. It doesn't alter the laws of physics. But it changes our perception. It invites us to reflect. It connects us with the mystery. And in the end, that's what matters. Because science is not just about explaining, but also about inspiring. And few things are as inspiring as the idea that even if they are unrelated, two such different phenomena have coincided in our gaze. One of the reasons 3I Atlas has sparked so much interest in the scientific community is because from its first observations, it showed chemical characteristics that make it different from any comet in the solar system. The comets we know are usually dominated by frozen water, with proportions of other compounds like carbon dioxide or carbon monoxide that vary depending on their history and place of origin. However, with this interstellar visitor, the rules seem to change. When telescopes began to study the composition of the coma, that cloud of gas and dust that surrounds a comet's nucleus when it activates upon approaching the Sun, the results were surprising. Instead of being dominated by water, as is the case with most local comets, the coma of 3I Atlas was saturated with carbon dioxide. It was not a secondary component, but the predominant one. That simple difference already makes it a rare object because it suggests that it was formed under very different conditions from the comets we know. To put it in perspective, in comets of the solar system, the typical ratio of carbon dioxide to water is usually less than 1, meaning there is always more water than carbon dioxide. In 3I Atlas, this proportion is inverted, with an approximate ratio of 8:1 in favor of carbon dioxide. It is like finding a river in the desert that carries another liquid entirely instead of water. A finding that forces us to rethink what we believed about the materials available in the formation of planetary systems. The James Webb Space Telescope, with its infrared sensitivity, was key in this discovery. Its instruments detected not only carbon dioxide, but also carbon monoxide, traces of water, ice, and more complex molecules like OCS, a compound of carbon and sulfur. The fact that these substances are present in an interstellar comet suggests that the chemical processes that form worlds are more diverse than we thought. Wherever 3I Atlas was born, the conditions were different, with an abundance of materials that are less common here. But the surprises don't end there. Another anomaly was the detection of cometary activity at greater distances than usual. Local comets usually remain inactive when they are far from the Sun, because the heat is not sufficient to sublimate their ices. However, 3I Atlas showed activity even beyond 3 astronomical units. This means that certain compounds inside it are so volatile that they are released even in regions where water remains frozen. In other words, it doesn't need to get too close to the Sun to start showing life. This detail, though technical, is important. It tells us that the comet is not only chemically different, but also dynamically strange. It behaves as if it were designed to shine ahead of time, to activate farther out than usual. And that is a clue about where it might have formed, perhaps in a region of its parent star's protoplanetary disk, where extremely volatile substances were abundant. There is also the matter of its color. The coma of 3I Atlas glows with a greenish hue, a result of the decomposition of diatomic carbon when illuminated by sunlight. Although this is not the first time we have seen this phenomenon in a comet, in this case, it is notable for its intensity and the moment it appeared. Instead of emerging when it was already very close to the Sun, it was observed in earlier phases of its approach. This suggests that diatomic carbon is present in greater quantities than in local comets, another clue that it comes from a different chemical environment. Researchers have also observed that the dust in the coma exhibits unusual properties when analyzing the polarization of the light it reflects. In particular, 3I Atlas shows a deeper and narrower negative polarization pattern than usual. This means that the dust particles in its coma have a different structure or composition, perhaps a mixture of more porous grains, or materials with optical characteristics that we do not normally see in comets in our system. In short, not only is its gas strange, its dust also seems to have a different origin. These chemical anomalies are more than a curiosity. They are direct clues about the diversity of planetary systems in the galaxy. For a long time, we assumed that what we saw in our solar system was representative of what happens in others. But the arrival of interstellar objects like 3I Atlas shows us that this view was limited. Out there around other suns, worlds are formed with different mixtures, with unexpected proportions of water, carbon, and sulfur. And from time to time, fragments of those worlds cross our path to remind us. What's interesting is that there is no total consensus on what this composition means. Some researchers suggest that 3I Atlas could have formed in a very outer region of its home system, where the most volatile ices were abundant and could accumulate in large proportions. Others believe that perhaps it was ejected from an environment in which the host star had characteristics different from the Sun, which would have altered the chemistry available in its disk. Whatever the explanation, the fact is that the comet behaves like a messenger from another place, bringing with it a chemical signature that doesn't match the one from home. Imagine what this means in a broader sense. Every time we observe an interstellar comet, we are seeing a small piece of a system we do not know, a fragment that was ejected millions of years ago and is now crossing our neighborhood. Every molecule detected in its coma is a piece of data about the diversity of the galaxy, a confirmation that worlds are not all formed in the same way. And although we do not yet have the complete map, these visitors allow us to draw the first lines of a much larger mural. In summary, 3I Atlas is not just a strange comet for coming from another system. It is also strange in its chemistry, its behavior, and its way of activating. It is a reminder that even in the most rigorous science, there is always room for surprise. And every time we detect an anomaly, we are faced with the possibility of broadening our vision of the universe. If anything has surprised astronomers in the first detailed observations of 3I Atlas, it is the presence of water where it should not exist in active form. When we think of comets, we usually imagine balls of ice that upon approaching the sun begin to sublimate. Water passes from a solid to a gaseous state and forms the characteristic bright coma. That view is correct, but only to a certain extent. In most of the comets we know, this activity begins when they cross a specific distance threshold, about 3 astronomical units from the sun. Beyond that boundary, the heat is insufficient for water to sublimate significantly. What is surprising is that 3I Atlas began to show signs of activity related to water and derived molecules long before reaching that distance. At more than 3.5 astronomical units, when it was still in regions where the sun barely heats, instruments were already detecting emissions characteristic of OH, a direct product of the decomposition of water under ultraviolet light. It was as if the comet was releasing water too soon. As if it did not respect the usual rules of behavior we are familiar with. The detection was made thanks to observations in the ultraviolet, particularly using the Swift telescope. Its sensors recorded the spectral signature of OH around the comet, confirming that it was water sublimating and being released into space. The estimated production reached tens of kilograms per second, a surprisingly high value for that distance. It is like seeing a glacier evaporate in the middle of winter, a phenomenon that does not fit with what we expect. How is this possible? One explanation is that 3I Atlas contains larger and more porous ice grains than normal. Instead of releasing water only on the surface when it receives heat, its interior could be ejecting icy fragments that sublimate slowly, even far from the sun. This would generate an extended, more diffuse activity, as if the comet were breathing ahead of schedule. Another possibility is that there are compounds that, by sublimating first, drag water molecules along with them, activating the process ahead of time. Whatever the cause, the important thing is that this behavior is not common. Solar system comets usually remain inactive until they get closer. To see an interstellar object release water in this way is a reminder that it comes from a different environment, where the initial materials and conditions were different. It tells us that not all comets follow the same script. Some have their own rules. Furthermore, the presence of water so far from the sun opens up fascinating questions about the history of this comet. In our system, it is believed that comets could have played a role in bringing water to the early Earth. If fragments like 3I Atlas travel through the galaxy with abundant water inside, this suggests that the distribution of this vital resource could be common in multiple star systems. Imagine what that means. We are not looking at a rarity, but perhaps a galactic norm. If water is abundant in interstellar comets, the possibility of worlds with oceans on other stars increases considerably. There is another interesting point. The detection of water at that distance also helps astronomers to calculate the size and structure of the nucleus. If a comet shows early activity, its nucleus is probably not compact and homogeneous, but rather porous, with internal pathways that allow gas to escape even from the depths. This makes 3I Atlas a perfect laboratory for testing theories on how icy bodies are built, and the scientific community was quick to debate the implications. Some argue that we are seeing an extreme but not impossible case, a comet with more volatile ice than normal. Others suggest it could be an indication that planetary systems produce a much more varied range of comets than we imagined. If we have already seen 3 interstellar objects in less than a decade, and at least 2 of them show radically different behaviors, what does that tell us about the diversity of materials out there? From a narrative point of view, the idea of water where it shouldn't be is powerful, because water is not just another chemical compound, it is the universal symbol of life. Every time we detect water beyond Earth, we feel closer to answering the question of whether we are alone. In this case, we are not talking about oceans or rivers, but about molecules escaping from an icy fragment traveling at 60 kilometers per second. And yet, that simple fact connects us with the possibility that water is common in the galaxy, that it is not a privilege exclusive to our planet. There is also a poetic contrast in all this. While the sun, close and familiar, stirs with storms that threaten our power grids and satellites, a remote visitor releases water ahead of schedule, as if to remind us that the universe is both dangerous and generous at the same time. A star that shows its power and a comet that gives us signs of water on the same temporal stage. 2 sides of the same cosmic coin. This finding also reinforces the importance of continuing to observe the comet in the remaining months of its journey through the solar system. If it already shows water at a great distance, what will happen when it is closer to the Sun, at its perihelion? Will we see an explosive increase in its activity? Will it fragment due to internal pressure? Or will it surprise us with even stranger behavior? Nobody knows, and that uncertainty is part of the charm. Ultimately, the detection of water in 3I Atlas beyond the usual distance for a comet reminds us that we should take nothing for granted. The cosmos is creative, varied, always ready to challenge our expectations. And every time it does, it gives us the opportunity to learn, to expand the limits of our understanding, and to feed our capacity for wonder. On September 7th, 2025, an astronomical event occurred that in itself deserved the world's attention: a lunar eclipse. During these phenomena, the Earth comes between the Sun and the Moon, casting a shadow that tints our satellite in reddish or coppery tones. It is a spectacle that always inspires fascination. But on this occasion, something else caught the attention of astronomers and those who were following the event with observational instruments. In the same sky where the eclipse was taking place, the comet 3I Atlas shone with a greenish glow that made it stand out among the stars. That green glow was not a simple visual effect. It is a chemical signature, a message that the comet transmits from its interior. Comets, as they approach the Sun, release gases that react with solar radiation. Among these gases is diatomic carbon, a molecule that, when excited by ultraviolet light, emits a characteristic glow in the green part of the spectrum. The result is a greenish halo that surrounds the comet's nucleus, and which, in cases like this, can be intense enough to be seen even with medium-sized telescopes. What is interesting about 3I Atlas is that its glow appeared unusually early and intensely. Many comets show green, but they usually do so in more advanced stages of their approach to the Sun. Here, however, the phenomenon was clearly visible during the eclipse, when it had not yet reached its perihelion. This suggests that the comet contains a significant abundance of compounds that release diatomic carbon, which distinguishes it from most mogul comets. The coincidence with the lunar eclipse gave this phenomenon a spectacular framework. Imagine the scene: the Moon covered by the Earth's shadow, acquiring that reddish tone that turns it into an enigmatic lantern in the midst of darkness, and near it, in the same celestial vault, a bright point with a greenish glow, a visitor from another system that added an unexpected color to the spectacle. It was as if nature had decided to mix two independent events into a single performance, giving us an unrepeatable cosmic choreography. The green glow also became a topic of conversation beyond the scientific community. Many amateur observers shared images on social media, and there was no shortage of interpretations filled with mysticism or popular curiosity. This is not surprising. Colors in the sky have always fascinated humanity. But what is most valuable is that, beyond the anecdote, this glow provides concrete data about the comet's composition. Every time we see green in a comet, we know that specific chemical processes are at work, and that helps researchers to reconstruct its origin. The fact that 3I Atlas showed this green with such intensity feeds the idea that it comes from a system with a different chemistry than ours. Perhaps it was born in a region where carbon was more present in the form of volatile compounds, or perhaps in an environment where the radiation from its star shaped the mix of materials differently. Whatever the case, the green of the comet is not just a visual ornament, it is a clue, a key to understanding a place that we will probably never be able to visit. From a narrative point of view, this phenomenon has a special charm. While the moon, our familiar satellite, was submerged in the Earth's shadow, a strange visitor shone with an uncommon color. The known and the unknown shared the sky, and we, from Earth, were witnesses to that encounter. It is not difficult to imagine how, in other times, such an event would have been interpreted as an omen. Today we understand it makes science, but the sense of wonder remains intact. Astronomers took advantage of the eclipse to obtain more precise data. During these events, the sky darkens unusually, reducing the background light and allowing for cleaner observations of nearby objects. It was the perfect time to study the comet and confirm the intensity of its green emission. The recorded spectra clearly showed the characteristic bands of diatomic carbon, confirming what the eyes already suspected. This also reminds us that astronomy is, in part, a matter of opportunities. The universe does not organize its calendar with us in mind. The eclipse and the comet coincided by chance, and the only reason we could see them together was because we were paying attention. That is the real gift, to be prepared to observe, to record, to marvel when two different phenomena overlap in our gaze. The green glow of 3I Atlas during the eclipse was not a simple aesthetic detail. It was the confirmation that this comet is chemically different, that it brings with it a message from another system. It was, furthermore, a reminder of how much we still have to discover. Because if 3 interstellar objects have already crossed our sky in less than a decade, and each one has shown surprising characteristics, how many more await us in the future? How many secrets from other suns will arrive disguised as small bright spots? For now, what we know is that on that September night, the sky gave us a double spectacle: the familiarity of a lunar eclipse and the rarity of a green comet from another system. And those of us who saw it or followed it through images and stories carry in our memory that moment when the ordinary and the extraordinary coincided on the same stage. Perhaps in a few years, when we look back and remember 3I Atlas, we won't first think of its numbers or its data, but of that image, an interstellar visitor shining green next to a red moon, a cosmic postcard that unites science and poetry. And that reminds us why we continue to look at the sky. Among the most intriguing findings related to 3I Atlas is one that, at first glance, may seem overly technical, almost reserved for specialists in optics and solar physics. This is the polarization of the light reflected from its coma and tail. However, behind those graphs and percentages lies a crucial clue about the nature of this interstellar visitor, a clue that clearly distinguishes it from the comets we know in the solar system. To understand the importance of this discovery, it is useful to explain what polarization means in simple language. Light, as we know, behaves like a wave. That wave can vibrate in multiple directions. When sunlight hits an object and is reflected or passes through particles of dust and gas, these vibrations can be organized into preferred directions. That is what we call polarization. By measuring the polarization of the light coming from a comet, astronomers can deduce the properties of the dust that composes it, its size, its shape, its internal structure, and even its origin. In the case of 3I Atlas, observations revealed something extraordinary: a deep and narrow branch of negative polarization, reaching values of around -2.7% at a phase angle close to 7 degrees. In simple terms, this means that the light behaved in an unexpected way when passing through or reflecting off the particles in the coma. Furthermore, the inversion angle, the point at which the polarization changes from negative to positive, was recorded at around 17 degrees, an uncommon value for local comets. Why is this important? Because this optical response indicates that the dust of 3I Atlas is not like what we usually find in the comets of our neighborhood. The particles seem to have a different structure, perhaps more porous or more complex, with compositions that alter the way they interact with light. In other words, the very physics of light is telling us that this visitor comes from an environment with different conditions, that its optical signature does not match that of the comets we know. Polarization studies of solar system comets have been useful for decades in classifying types of dust and comparing their evolution. Normally, the negative branch is shallower, and the inversion angle is larger. Seeing such a marked pattern in 3I Atlas was a surprise that immediately raised questions. What kind of materials make up its nucleus? Could it be particles with a higher content of organic compounds? Or perhaps grains with fractal geometries that scatter light in an unusual way? Beyond the technical, what matters is the conclusion. The dust of 3I Atlas is different, and this difference is not a minor detail, because dust is, in essence, the raw material from which planets, moons, and other bodies are formed. To observe its rarity is equivalent to holding a piece of another star system in our hands and discovering that it does not follow the same rules as ours. The extreme negative polarization also has practical implications. It means that the models we use to interpret local comets cannot be directly applied to this visitor. We need to adjust our theories, consider new scenarios, and open ourselves to the idea that the diversity of interstellar dust is much greater than we believed. Every time an object like this crosses our system, it gives us a chance to check. And what we see so far is that none of them behave the same as the others. From a narrative perspective, there is something almost poetic in the fact that light reveals secrets to us in this way. We don't need to touch the comet or send a ship to scrape its surface. It is enough to look at the light that surrounds it and analyze how it organizes itself, how it vibrates, how it changes direction. That light travels millions of kilometers to reach us, and on its journey, it carries the encoded history of the particles it encountered. Polarization is like a whisper, a message hidden in the light, which tells us what the visitor is made of. The finding is also related to the cosmic coincidence that we have been highlighting. While the sun shows more activity and launches storms into space, the comet reflects that light in unusual ways. It is as if both protagonists of this story, the sun and 3I Atlas, are speaking to us at the same time, one with its overflowing energy and the other with the mystery of its strange dust. And we, from Earth, are fortunate to hear both messages. Imagine what this means for the future. Every time we detect an interstellar object, we can apply these same techniques. If the next visitors show similar polarizations, we will know that there is a pattern, a common signature of comets from outside. But if each one behaves differently, as it seems so far, we will confirm that the diversity is even greater than expected. In either case, our view of the cosmos expands. Of course, science is cautious. A single object is not enough to draw definitive conclusions, but the fact that in less than a decade we have had 3 visitors, Oumuamua, Borzov, and now 3I Atlas, is already an indication that these opportunities are not as rare as we thought. And each one brings with it a different mystery, a strange shape, an unusual chemistry, a dust that behaves in an unexpected way. The extreme polarization of 3I Atlas, far from being a technical detail, is concrete proof that we are dealing with a special object. It is a reminder that the secrets of the universe are not always revealed in grandiose spectacles. Sometimes they are hidden in the way light vibrates, in percentages that seem small but contain stories of other suns and other worlds. Thus, as we continue to observe its journey towards perihelion, we know that we are not looking at just any comet. We are looking at a foreigner that brings with it a different dust, a different light, a different signature, and in that seemingly minor detail lies the greatness of its message. One of the most fascinating practices in modern astronomy is the search for what are known as precovery images. The term comes from the combination of pre and recovery and refers to the identification of an object in photographs taken before its official discovery. In other words, once a comet, asteroid, or minor planet is detected, astronomers review observatory archives to see if unknowingly someone had already captured it in their images. This is exactly what happened with the Comet 3I Atlas. It was officially detected in July 2025 by the Atlas telescope system in Chile. But shortly after, teams of astronomers began to review databases of images taken weeks and even months earlier. And there it was, a faint point of light that had already been recorded by other telescopes, but at that time went unnoticed because it did not stand out from the background of stars. Precovery images are much more than a curiosity. They are a key tool for improving orbital calculations. Each new retroactive detection adds another data point to the equation, another point on the trajectory that allows the object's path to be traced with greater precision. In the case of 3I Atlas, the previous records confirmed what was already suspected, that its orbit is hyperbolic, and that it is, without a doubt, an interstellar visitor. This type of retroactive discovery also tells us about the enormous value of astronomical archives. For decades, observatories around the world have accumulated millions of images of the night sky. In many cases, these images were taken with specific objectives, studying galaxies, variable stars, or supernovae, but they also recorded other objects that were not recognized at the time. It's like having a trunk full of old photographs and discovering years later that in a corner there is a person we had not noticed. For 3I Atlas, the precovery images made it possible to trace its path further back in time and to see how its brightness and coma evolved before it was announced to the world. This information is valuable because it helps to understand how its activity began, at what point it began to release gases, and how it behaved at greater distances from the Sun. Furthermore, this retroactive finding connects in an interesting way with the narrative of the cosmic coincidence. While the Sun was beginning to show its agitation with more spots and flares, 3I Atlas was already there, silently advancing into the inner solar system. No one noticed it, but it was already part of the story we are telling. Its official discovery was just the moment we focused on it clearly, but the truth is that its journey had begun much earlier. This detail also reveals how limited our observation capabilities still are. If such a unique object could go unnoticed in images taken by modern telescopes, how many more will be hidden in the archives, waiting to be recognized? The search for precoveries thus becomes a reminder that the sky holds secrets even in photographs we already think we know. Narratively, there is something almost poetic in this idea. The comet was there, traveling with its greenish glow, captured in digital images, but with no one paying attention to it. Like a silent guest in a crowd, waiting for the moment when someone would notice its presence. And when we finally saw it, we understood that it had been with us before, without us knowing. The practice of precovery also tells us something about the future. With the arrival of new generation telescopes like the Vera C. Rubin Observatory, which will record the entire sky every few nights, the amount of available data will grow exponentially. This means that, in the coming years, the detection of interstellar objects will become increasingly common, and precovery images will be available almost immediately. It will not be unusual for us to discover a new visitor and within hours find dozens of previous photos of its journey. But at this moment, with 3I Atlas, the retroactive finding has a special flavor. It reminds us that the story of this comet did not begin in July when it was announced. It began much earlier, when it crossed the invisible border of the solar system and began to be captured, without anyone knowing, in the photographs of observatories. It is a reminder that discoveries are not isolated points, but part of a broader continuum that we only understand over time. Ultimately, the precovery images not only improved the orbital calculations for 3I Atlas, but they also expanded our narrative about it. They allowed us to see it as a traveler who was already present, silent and discreet, long before we recognized it as a protagonist. And they invite us to reflect on how many other travelers have crossed the sky without us ever noticing, leaving only an unnoticed trace in some forgotten archive. So far, we have stuck to what science confirms: an unusually active sun and an interstellar comet with chemical characteristics that make it different from anything we know. But in this segment, we are going to allow ourselves a speculative turn. Not because science supports it, but because imagination is also a powerful tool. The question we pose is simple, yet intriguing. What if 3I Atlas were influencing the sun's behavior? At first glance, it seems impossible. The sun is gigantic, with a mass equivalent to more than 99% of the entire solar system. A comet, no matter how rare, is just a cosmic pebble in comparison. How could such a small object affect such an immense star? That is the scientific logic. And yet, there is something in the coincidence of both phenomena, the solar awakening and the comet's approach, that invites us to play with the hypothesis. We can imagine an alternative scenario in which 3I Atlas, coming from another star system, brings with it a residual magnetic field, exotic particles, or materials that interact in an unusual way with the solar plasma. Upon entering the sun's sphere of influence, this comet could act as a catalyst, like a spark that alters the star's magnetic dynamics. It would be like throwing a stone into a seemingly calm lake and watching ripples form and spread outwards. Another speculative possibility is that the comet's tail, laden with gases like carbon dioxide and uncommon molecules, interacts with the solar wind differently. Perhaps these interactions generate local disturbances that, magnified by the sun's magnetic field, trigger more frequent or intense eruptions. It would not be a case of the comet controlling the sun, but of it acting as a reminder, a visitor that awakens reactions in a sleeping host. From a more poetic perspective, we could say that 3I Atlas brings with it the echo of another star, that as it crosses our neighborhood, its strange composition and greenish glow provoke a kind of resonant memory in the sun, as if it recognizes in this visitor a sign from the places where suns are also formed. And in this resonance, ours responds with unusual activity, as if lighting up to welcome a distant traveler. Although these scenarios are speculative, they serve an important narrative function. They allow us to explore the relationship between apparently disconnected phenomena and to ask ourselves if, in such a vast universe, we can always be sure that coincidences are just that. What if there are connections we do not yet understand? What if the universe is more intertwined than we think? Imagine, for example, that in the future, astronomers were to detect a correlation between the arrival of interstellar objects and peaks in solar activity. It would be a revolutionary finding, capable of completely changing our view of the cosmos. Suddenly, these visitors would not be just passing curiosities, but actors capable of influencing the dynamics of stars. And although today this idea has no scientific basis, raising it opens the door to reflections on how little we know. We can also look at it from the perspective of the philosophy of science. Much of human progress has consisted of turning the impossible into the possible. For centuries, meteorites were thought to be myths, until someone dared to seriously propose that stones could fall from the sky. It was thought that planets around other stars were improbable, until technology confirmed thousands of them. Who can say that in the future we will not discover unsuspected interactions between interstellar objects and the activity of stars? These types of scenarios, though speculative, serve another function. They awaken the listener's curiosity. Because beyond what we can confirm, they invite us to look at the sky with different eyes, to ask ourselves what other connections might exist in that sea of phenomena, to accept that, even if current science says there is no relationship, the mystery is always present, and there will always be questions we don't yet know how to ask. In fact, thinking about the possibility of Three-Eye Atlas influencing the sun connects us with an ancient tradition, that of seeing meaning in the heavens. Our ancestors interpreted eclipses, conjunctions, and comets as signs. Today, with more knowledge, we can separate myth from reality, but the fascination remains the same. And perhaps, deep down, we need this mix of rigor and wonder to keep our relationship with the universe alive. In the end, the most valuable part of this exercise is not the hypothesis itself, but what it reminds us of, that the universe is a dynamic place, where everything is in constant motion and interaction, that interstellar visitors are more than curiosities, they are reminders that we are not alone in the galaxy, and that the sun, though it seems eternal and immutable, also has its awakenings, its moments of fury, its cycles that affect us directly. Thus, this speculative scenario leaves us with a powerful idea. Maybe, just maybe, Three-Eye Atlas arrived just at the moment our sun needed to wake up, not because it caused it, but because their coincidence forces us to look closer, to observe in greater detail, to discover in this superposition of phenomena a reason to be amazed once again. So far, we have played with the speculative idea that the interstellar visitor could influence solar activity. Now let's turn the question around and explore an inverse scenario. What if it is the sun, in its state of agitation, that is affecting Three-Eye Atlas? In this case, the hypothesis does not sound so far-fetched. After all, we know that comets are extremely sensitive to solar radiation. Their behavior depends directly on the distance to the sun and the intensity of the energy they receive. An inactive comet, which looks like just a piece of ice and rock in deep space, can transform into a bright and dynamic spectacle when it crosses into our star's heat zone. If the sun is also going through a period of unusual activity, with more intense flares, coronal mass ejections, and denser solar winds, then it is reasonable to imagine that this comet would be affected in extraordinary ways. Imagine the scene. Three-Eye Atlas is approaching its perihelion, still with that distinguishing greenish coma, when suddenly the sun unleashes a series of more powerful storms than normal. The solar wind, charged with high-energy particles, strikes the visitor. The comet's tails, the gas tail and the dust tail, lengthen and distort, responding to the onslaught. What would be a gentle change in other comets could here transform into a chaotic spectacle. The tail could split into multiple fragments, twist into unexpected shapes, or even show sudden disconnections when part of the material abruptly breaks away. This phenomenon of tail disconnection has already been observed in local comets. When a coronal mass ejection hits a comet, it can literally tear away its gas tail, which then grows back. With a more active sun than normal, the probability of this happening increases. And if the comet in question is also interstellar, with an uncommon composition and an abundance of unusual volatile gases, the result could be even more spectacular. We could see tails that change color, length, and direction more rapidly than in usual comets. Another possible effect is that the comet's activity could intensify much earlier and more violently. We have already seen that 3I Atlas releases water at greater distances than expected. If we add to that a sun that radiates more energy, it is reasonable to think that its sublimation would accelerate. It could produce sudden bursts of gas and dust, increasing its brightness in a matter of hours or days. For astronomers, this would be both a challenge and an opportunity. Each sudden increase in activity would offer unique data on its composition and internal structure. But there is an implicit risk. Comets, though spectacular, are fragile. They often have irregular nuclei with fissures that make them vulnerable. An excess of internal pressure can cause them to fragment, as happened with comet Shoemaker-Levy 9 before it crashed into Jupiter. If the awakened sun exerts too much pressure on 3I Atlas, there is a possibility that it could break into pieces before completing its perihelion. It would be a dramatic outcome. An interstellar comet that traveled millions of years from another system, only to disintegrate at its first close encounter with an active star. From Earth, such a scenario would be doubly fascinating. First, because we would witness the fragmentation of an interstellar object, something never before seen in such detail. Second, because it would give us the opportunity to analyze its interior, revealing materials that normally remain hidden beneath the surface. Each released fragment would be like a window into the chemistry of another star system. In scientific terms, the destruction of the comet would be as valuable as its survival. In this scenario, the sun would not be a mere spectator, but a main actor shaping the fate of 3I Atlas. Its unusual activity would turn it into a sculptor, carving the visitor with flares, storms, and radiation. And we would be witnesses to this interaction, observing how a familiar star and an unknown traveler meet in a dance of energy and fragility. Narratively, the idea also has symbolic force. The sun, our guardian, shows its power against a stranger entering its domain. 3I Atlas, no matter how distant its origin, cannot escape this influence. It is a reminder that all forms of matter that approach a star are doomed to respond to its energy, and that deep down, stars are the supreme judges on the cosmic stage. Beyond the poetic, this scenario invites us to reflect on the fate of interstellar travelers. Many of them probably end up destroyed by getting too close to active stars. Only a few survive long enough to continue their journey intact. In this sense, every object like 3I Atlas is an unlikely survivor, a fragment that managed to cross space for millions of years and now faces its greatest test in the vicinity of a sun that is not calm but in full agitation. This what if has an additional value. It reminds us of the fragility of the phenomena we observe. The comet could disappear in a matter of weeks, leaving only a trail of dust in its path. The sun could return to its relative calm as if nothing had happened. But for us, who witness it, it will be an unrepeatable moment, an opportunity to see how the power of a star can transform or destroy an interstellar visitor. In the end, The answer to the question, and what if the awaking sun affects 3I Atlas, is probably affirmative, although to varying degrees. We do not know if it will fragment it, make it shine more intensely, or simply deform its tails. What we do know is that the encounter between a strange comet and an agitated sun will be anything but boring, and that is enough to keep us attentive. Waiting for the coming weeks with the expectation of someone who knows that something unique is about to happen. When we talk about 3I Atlas, we don't do so in a narrative vacuum. Its story resonates because this is not the first time we have received a visit from an interstellar traveler. Before it, two other objects broke the routine of the sky and reminded us that the galaxy is much more connected than we imagined. Those objects were Oumuamua, discovered in 2017, and Borisov, observed in 2019. Each left a different mark on the memory of astronomy, and together they help us understand why 3I Atlas is so important. Oumuamua was the first. Its discovery was a true scientific earthquake. It was not a bright comet or a typical asteroid. It moved too fast, with a hyperbolic orbit that betrayed its interstellar origin. But what made it unforgettable was its shape and behavior. Calculations indicated it had an elongated structure, like a cosmic cigar or perhaps a flattened plank. Its brightness varied strangely, suggesting it was tumbling chaotically, and most disconcertingly, as it moved away from the sun, it accelerated in a way that could not be explained by gravity alone. Astronomers proposed that the acceleration was due to a slight push caused by the release of gases, as occurs in comets. But the curious thing was that no coma, no visible tails, and no clear signs of sublimation were detected. This left the door open for bolder explanations, some even related to the possibility that it was an artificial object, a probe sent by another civilization. Although most scientists lean towards natural explanations, such as a fragment of solid hydrogen or a nitrogen iceberg, the shadow of that mystery still lingers. 2 years later, Borisov arrived, and its case was different. From the beginning, it showed the classic behavior of a comet: a bright coma, a defined tail, evident sublimation of water ice. It was clearly an interstellar object, but it was more similar to what we already knew. That didn't make it less important. Borisov was confirmation that interstellar visitors were not unique rarities. Its chemistry, however, also showed differences. It contained more carbon monoxide than typical comets in our solar system, suggesting an origin in a colder region of its host star. The sequence of these three visitors, Oumuamua, Borisov, and now 3I Atlas, allows us to make comparisons. Each one provides a different piece of the puzzle. One was mysterious and challenging, another was more familiar but equally revealing, and the third combines chemical rarity with a special cosmic context. It is as if the galaxy has sent us three different messages, in different envelopes, to remind us that the diversity of worlds is infinite. If we look at 3I Atlas in the mirror of these predecessors, we see it with greater clarity. It is not as enigmatic in its shape as Oumuamua, but it does share with it the fact that it is an object that will never return. It is not as similar to local comets as Borisov, but it does confirm that interstellar visitors can carry radically different chemical characteristics. And what is most remarkable is that in less than a decade, we already have 3 examples. What once seemed impossible, detecting an interstellar traveler, is becoming part of our scientific experience. This forces us to rethink our expectations. If in centuries of observations we recorded none, and suddenly, in less than 10 years, we detect 3, what does it mean? Is the galaxy more full of these objects than we thought? Or has our technology simply reached the necessary sensitivity to see what was always there? The latter is most likely, But in any case, the effect is the same. We now know that we are not isolated, that our solar system is constantly being crossed by fragments from other places. The parallel also invites more philosophical reflections. Each visitor is, in a way, a mirror in which we see ourselves. Oumuamua reminded us that there are still mysteries that defy our understanding. Borisov showed us that familiarity can also come from outside, that the processes that create comets are not exclusive to the Sun. And 3I Atlas, with its strange chemistry and its coincidence with a restless sun, reminds us that we live in a dynamic universe where the improbable becomes reality. Furthermore, the way we have received each one reflects our own evolution. With Oumuamua, bewilderment dominated the news, even with theories about alien ships. With Borisov, the scientific community reacted more calmly, focusing on the chemical details. And with 3I Atlas, we arrived prepared, with telescopes like the James Webb ready to obtain data at wavelengths that were previously out of our reach. Each visitor has caught us in a different state of readiness, and that is also part of the learning process. We cannot help but wonder which will be the next. If in less than 10 years we have seen 3, it is logical to expect more. Perhaps we will soon discover an interstellar object visible to the naked eye, so bright that millions of people can observe it without telescopes. Or perhaps we will find one with a trajectory that brings it so close to Earth that it can be studied in detail. Each new visitor will be different, and each will add a nuance to the cosmic symphony we are just beginning to hear. In this segment, we have placed 3I Atlas alongside its predecessors, and what emerges from this comparison is clear. We are not facing an isolated rarity, but a trend. Interstellar visitors are part of the history of the solar system, even though we are only now opening our eyes to see them. Each one is a mirror that reflects something different from the galaxy. And together, they tell us that the universe is full of travelers, crossing impossible distances, leaving brief traces in our skies. At this point in the narrative, we have already discussed data, chemistry, trajectories, and hypotheses. We have followed 3I Atlas on its journey, watched it interact with a restless sun, and compared it to other interstellar visitors. But now it is worth pausing for a moment, taking a deep breath, and looking at the big picture from another angle. Because beyond the figures and calculations, what truly remains etched in memory is the wonder. And it is here that the philosophy of the sky is born, a reflection on what it means for us, as a species, to witness these phenomena. Humans have always sought meaning in the firmament. Since the earliest civilizations, looking up was an act fraught with significance. The Babylonians drew star maps to predict the fate of kings. The Mayans built temples aligned with the sunrise and the path of Venus. The Greeks imagined constellations as mirrors of their myths. Looking at the sky was, at the same time, a way of explaining the inexplicable and connecting with something larger than oneself. Today we have telescopes, mathematical models, and space probes. We know that comets are not omens, but bodies of ice and dust. We know that the sun is not an angry god, but a sphere of plasma governed by physical laws. But the wonder remains the same, because although we have replaced myths with science, the feeling of smallness and marvel remains intact. 3I Atlas gives us an opportunity to revive that feeling. It doesn't matter that we know its orbit is hyperbolic or that its coma is rich in carbon dioxide. What we feel when we contemplate it is the same as what our ancestors felt when they saw a comet shine in the night sky. The certainty that we are not alone, that the universe is vast, and that there will always be something new to discover. The coincidence with solar activity reinforces this feeling. While our star shows a more agitated face, a traveler from another system crosses our neighborhood. It is as if the cosmos were speaking to us in two voices at the same time, one familiar and close, the other distant and mysterious. And in this dual voice, we find a profound message. The universe is dynamic, alive, impossible to pigeonhole into definitive explanations. Cosmic wonder also has practical value. It is not just a poetic emotion, but a force that drives knowledge. Much of modern science was born from curiosity, from the ability to be amazed by the unknown. Without that wonder, we would not have launched telescopes into space or probes to the planets. We would not have calculated orbits or detected molecules in the atmospheres of distant worlds. Wonder is the engine that transforms questions into discoveries. And there is something more. Wonder unites us. Few experiences are as universal as looking at the sky. It doesn't matter the language, the culture, or the era. We have all looked up and felt the same thing in the face of a comet, an aurora, or an eclipse. In a world full of divisions, the firmament is one of the few stages that still reminds us of our shared humanity. When millions of people watch the same aurora caused by a solar storm, or when social media is filled with photos of an interstellar comet, what is happening is not just science, it is community. That is why talking about the philosophy of cosmic wonder is not an abstract luxury, but a necessity. It helps us remember that, even though we live in illuminated cities and are surrounded by technology, we are still part of an immense universe, and that the best way to relate to it is with humility, with curiosity, and with a willingness to be amazed. In this sense, 3i Atlas is not just a passing object. It is a mirror of our own desire to explore, to understand, to connect with the unknown. It reminds us that the galaxy is alive, full of fragments traveling for millions of years, crossing star systems, and that some of them are lucky enough to coincide with our gaze. It reminds us that, although we believe ourselves to be masters of the Earth, we are merely spectators in a much larger play. There is also a personal lesson. Every time we talk about the sky, we are also talking about our life down here. The interstellar comet that crosses without stopping is a reminder of how fleeting everything can be. The sun's activity, which can disrupt our communications and satellites, reminds us that we depend on forces we do not control. And yet, in the midst of this fragility, we find beauty. The green glow of a coma, the dancing light of an aurora, the shadow of an eclipse, all are reminders that even in the ephemeral there is greatness. At its core, the philosophy of cosmic wonder is a call to reconcile ourselves with uncertainty. Science gives us explanations, but there will always be open questions. And far from being a problem, this uncertainty is what keeps us awake, attentive, ready to continue exploring. As Carl Sagan said, we are a way for the cosmos to know itself. And each interstellar visitor is an opportunity to expand that self-knowledge. Thus, when thinking about 3i Atlas, we should not limit ourselves to its numbers or its chemical data. We should see it for what it is, a reminder that we live in a universe full of surprises, where there is always something that can alter our expectations. A reminder that the sky is not a static backdrop, but a constantly moving stage. And above all, a reminder that wonder is still our most powerful tool for learning and for feeling alive. September 2025 will not go unnoticed in the records of astronomy, nor in the memory of those of us who looked up at the sky during those nights. It has been a month in which celestial phenomena seemed to multiply, as if the firmament wanted to remind us that it is never at rest. Asteroids that grazed our orbits at safe distances, newly discovered comets that unfurled nascent tails, a lunar eclipse tinged with red, and, in the midst of it all, two protagonists who stole the show, a restless sun and an interstellar comet with a strange name, 3i Atlas. It is not common for so many events to be concentrated in such a short time. Usually, astronomy gives us isolated events, a meteor shower in August, an eclipse in May, a visible comet every few years. September, on the other hand, has been like a celestial festival, a reminder that the cosmos also has its intense seasons. For scientists, it has been an opportunity to collect valuable data. For amateurs, an occasion to observe with telescopes or even with the naked eye. And for the storytellers of the sky, an unrepeatable month to weave stories that mix science, mystery, and poetry. The most striking thing about this month has been the sense of coincidence. On the one hand, the sun showing more agitated behavior than predicted, with sunspots and flares that exceeded expectations. On the other, an interstellar comet crossing our system for the first and only time, leaving behind a greenish glow that recalled its alien nature. Both phenomena, so different and with no proven causal relationship, coincided in the same time and on the same stage. The sky we share every night. This coincidence turns September into a mirror of our own curiosity. Because what really fascinates us is not just the data, but the superposition of stories. The sun, the source of life and energy, stirs as if awakening from a slumber. The comet, a lonely traveler from another system, approaches and lets itself be seen, knowing that it will never return. And we, from this small blue planet, stop to observe them, to relate them, to ask ourselves if there is perhaps a hidden link, or if it is simply a symphony of chances. In a more human sense, September taught us something about our own need for wonder. Every aurora borealis visible in unexpected places, every image of the comet taken by telescopes and shared on social media, every news story about solar storms reminded us that we are still a species that looks for signs in the sky. We no longer interpret these signs as omens from gods, but we still give them a deep emotional value. They make us feel part of something larger, something we do not control but can contemplate with humility. A reflection on this month also touches on a philosophical aspect, the ephemeral nature of these phenomena. 3I Atlas will continue its journey, moving away, never to return. The sun, after its maximum activity, will return to a quieter phase in its cycle. The lunar eclipse was recorded in photographs, but it already belongs to the past. The only thing that remains is the memory, the record in our minds and in our archives. And perhaps that is enough. We do not need the spectacle to be eternal for it to have value. Its beauty lies precisely in its fleetingness. September also left us with a lesson on perspective. In the midst of daily routine, of earthly concerns, the sky became a reminder that we inhabit a living universe. That while we resolve small matters down here, colossal stories are unfolding up there that affect us in visible and invisible ways. That every solar storm can interfere with our satellites. That every interstellar visitor is a time capsule from another star system. And that, although we feel we are the center of our own narrative, we are actually just a point within a larger symphony. Perhaps the most valuable thing about this cosmic month is what it awakened in ordinary people. Children asking why the moon looked red. Young people sharing photos of the green comet on social media. Adults who, after years of not looking at the sky, stopped for a few minutes to watch an aurora. That is the true legacy of September. Not just scientific data, but personal memories, shared emotions, small sparks of curiosity that may ignite future vocations. From a narrative perspective, September was a perfect reminder of what it means to tell stories of the sky. It's not just about explaining phenomena, but about inviting us to reflect on what we feel when we witness them. An active sun and an interstellar comet can be analyzed with graphs and spectra, but they can also be narrated as protagonists in a play in which we are the audience. And this dual perspective, scientific and poetic, is what gives these stories their value. Thus, as we close this segment, The reflection is clear. September 2025 was not just any month. It was a month in which the sky spoke to us with more intensity than usual. A month in which science and emotion met on the same stage. And although the phenomena may pass, although the comet may continue on its way, and the sun may change its phase, what remains is the certainty that we live in a universe full of surprises, and that, from time to time, these surprises are concentrated in a single moment, as if the cosmos wanted to remind us that it is always worth looking up. The sky, in the end, always returns to its apparent calm. Solar storms diminish, comets move away, auroras dissipate. What remains is the memory of those who were attentive, of those who looked up at the right moment. September 2025 will be remembered as an unrepeatable month, a month in which the celestial vault gave us a double spectacle, a restless sun and a green comet from another star system. Two different protagonists, united by the coincidence of occurring in our time. The comet 3I Atlas is already preparing for its farewell. It will never return. Its hyperbolic orbit will take it to regions where no human telescope can follow it. Its green glow, its strange chemistry, its tales stirred by the solar wind will be recorded in archives and scientific articles, but above all, in the memory of those of us who knew how to look at it with wonder. It will be a footnote in the history of astronomy, yes, but also a spark in the history of our collective curiosity. The sun, for its part, will continue its cycle. After these months of agitation, the solar maximum will arrive, and then the relative calm of a new minimum. As always, it will mark our destiny. Every sunrise, every sunset, every moment of light on Earth will depend on its constancy. But September reminded us that although it seems eternal and unchanging, it also has its awakenings, its moments of intensity, its phases that affect us in invisible and visible ways. In this conclusion, it is worth looking back and recognizing what this month taught us. It taught us that the universe does not accommodate our routines, that while we live worried about everyday matters, colossal stories are happening up there on scales we can't imagine. It taught us that the ephemeral has value, that even a visitor who will never return can leave a lasting mark on us. And it taught us, above all, that wonder is still our best tool for understanding the cosmos. There is something profoundly human in the way we tell these stories. It is not enough to say, there were more intense sunspots, or a comet passed by. We want to give them a framework, a narrative, a meaning. We want to see in the sky not just data, but also metaphors. And that is not a mistake. It is part of what makes us human. Science explains, but narrative connects. And September gave us the opportunity to use both perspectives at the same time. We can imagine future generations reading about this month in astronomy books. For them, it will be just another record, a data point in a timeline. But for those of us who lived it, it will be much more. It will be the memory of nights when the moon was tinged with red, of unexpected auroras in temperate skies, of a green comet that will never return. It will be the certainty of having witnessed a fragment of cosmic history. At the same time, this conclusion is not final, because if astronomy has taught us anything in recent years, it is that interstellar visitors are no longer so rare. First, it was Oumuamua, then Borisov, now 3I Atlas. Who will be next? What mysteries will they bring? Perhaps an even stranger object will arrive. Perhaps one closer. Perhaps one so bright that millions can see it with the naked eye. The only thing certain is that there will be more, and that each one will be a new opportunity to look at the sky with renewed wonder. Meanwhile, the reflection remains open, not about numbers or orbital models, but about our relationship with the universe. Because in the end, talking about comets and suns is talking about ourselves, about our capacity for wonder, our vulnerability, our curiosity. The cosmos does not need us to look at it, but we need to look at it to remember who we are. September 2025 will go down in history as an unrepeatable month, a reminder that the universe is alive, that it always holds surprises for those who raise their eyes to the firmament. And perhaps that is the greatest gift of this time, the certainty that no matter how advanced we think we are still spectators of an immense play that never ends. Thus, when the comet is lost in the darkness and the sun returns to its usual rhythms, the lesson will remain with us, that the ephemeral is also eternal in memory, that the distant also touches us, and that as long as there is someone willing to look up, the sky will continue to be a mirror in which we see our own greatness and our own smallness reflected. Because in the end, what matters is not just what we saw, but what we felt. And this month, looking at a restless sun and a green comet, we felt that the universe still has much to tell us.